So here's the remainder of today's lecture. So let me just make this slightly larger for you. You were discussing ANCOVAs, if I'm not mistaken, and I was just about to give you a sample write-up, which I actually think I did in class. So what you write in your report is that a one-way ANCOVA was conducted to compare openness across groups whilst controlling for extroversion. There was a significant effect of cultural group, and then you would report the f-test and the p-value. So f-test, the degrees of freedom, the actual f-value, and then the p-value. And in addition, sometimes people would report the effect of a covariance, and again you would report the f, the degrees of freedom, the value, and the corresponding p-value. And as you would have then done also for ANOVAs, you would describe post hoc differences, and also you would explore perhaps how extroversion is associated with openness to experience. Perhaps you would do a correlation or a plot to further discuss that. Now there's a non-parametric alternative, and you can look at the LM-PERM package to look at that further. But let's move on to Manova. So Manova is the M is for multiple or multivariate, and it has all the previous assumptions plus multicollinearity. So it's you also have to then have multivariate normality, and you need homogeneity of the covariances as opposed to just variances. So those are the assumptions for Manova. Something you might have come across with also with your undergraduate stats, and we'll run you through it. So first through all the assumptions. So we can do the multivariate Shapiro test, and you can click on the link to find out more. You should note that it's a sensitive sample size, and if you have a large sample, then even small deviations will lead to significance. So use it conservatively, and perhaps you might not want to use it at all. This is how you would go about doing it. So we need the RV8 Memoir package, which you might have also used for some other things already. Note also that dplyr still has to be loaded. We create a new data frame, which is just all the multivariate things we want to evaluate, and this would then work via dplyr. Now, because some other packages also use dplyr, it's good sometimes to use this type of command. So sometimes when you run into an error, you might want to use those to avoid that you get an error from loading the package. So that would be the construction of a data set, and then we would do mShapiro.test for the multivariate norm. And so, in case it wasn't obvious, we want to use the Manova to conduct an analysis where we have multiple dependent variables. So that's where the M comes from. So this gives us a significance test. So in this case, all our dependent variables are all the personality facets. So neuroticism, extroversion, openness to experience, agreeableness, and conscientiousness. It will give us a W value, and it gives us a P value. In this case, it's significant, but it's quite easily significant. There's a bunch of alternative methods where you can click and find out more about some of these. So just one example is a Mardia test, and so this is how you would go about doing it. So we require the MVM package, and then we again use the data frame with just all our dependent variables in it. And this one nicely prints out the p-value for skew and the p-value for kurtosis, and then for the overall tests. And so the conclusion is that our data are not multivariate normal. Is it bad? It sort of depends how bad you think it is. So for large samples, it is violated, but it could be worse, and we can actually also ask the Mardia test to sort of plot it. And so if it was doing perfectly well, we should find most points across this line. And it seems that, so don't worry too much about what's here on the x-axis and what's here on the y-axis, but focus mostly on what's on this line. So there's some deviations from this line, as you can see here, but it could be way worse. And again, central limit theory comes to the rescue. So the solution would be that you check for outliers in your data, multivariate outliers, and you would exclude those. And ideally, you would then report both analyses. You could try transformations of your data. You can read more about the Box-Cox transformation, which could be a solution. But most of the time, the central limit theorem will come to the rescue again. And so some statistics will also be quite robust to deviations from normality. So again, the central limit theorem comes to our aid, and perhaps it's not as bad as we expected. As with the univariate case, we also want to find out whether homogeneity of variance applies. So you would run a bunch of those tests, as I've shown you before, a bunch of Levi's tests. For every single dependent variable, you would examine those. I've not done them here, but you can run these on your own. We've done them for openness and extroversion in class, and you would do it for the remainder. Now there's also homogeneity of covariances, and that's usually tested with a box M test, but you should approach it with care. It's very easily significant, and therefore usually a higher significance threshold is set, p is 0.001, as opposed to your 5% significance. You can read more again here by clicking on that link, but you should just be aware it's very easily significant. If we want to conduct it, we would use BioTools, the package. You need to make sure that's installed first. And then the command is boxm multivariate norm, which is the data frame which we made containing all our dependents. And then this is the groups which we are examining. Note that you could also use group fact, like the factorial variable which we made, but here I've just used group. Okay, and so the conclusion here actually is that we shouldn't worry too much about homogeneity of covariances because that's not significant, and you should be aware that this test is quite easily significant. So that's good news, at least in terms of homogeneity of covariance. Now the actual Manova, so this is an ANOVA with basically multiple dependent variables. So we have 5 in our case, the 5 personality facets or personality scores. So how would we want to go about doing this? Again, if I'm not mistaken, this is part of base R, so it has a Manova command in there. So we're going to make an object called Manova model, and then Manova cbind, as you remember, is to combine things, and then NEAOC, the tilde, and then group fact to say that this is the independent variable, the data frame where those are stored. And again, we first built a model, and then we want to summarize it. So then we get summary Manova model. Okay. What we then get is this type of output. Again, you notice the degrees of freedom. You also know the numerators and denominators degrees of freedom. Those correspond to PLI's trace, which you might come across, an approximate F value, and a significance test of that F value. And as you can see, it's highly significant. So that suggests that the personality profiles between these groups vary based on those 5 traits, based on neuroticism, extroversion, agreeableness, openness to experience, and conscientiousness. Okay. So other measures exist, but PLI's trace is perhaps the most commonly reported. You can find out more about them here, and also the math behind it. I won't run you through it, but perhaps your supervisor for your project will ask for other measures, and you can find all of them there in those. And also in the references of this lecture, you can find other alternative measures for Manova. So PLI's trace is most commonly reported, and a sample report would be as follows. A Manova was conducted with 5 dependent variables: neuroticism, extroversion, conscientiousness, agreeableness, and openness to experience, and cultural group as the between subject factor. And then a statistically significant effect was found, and then we would just report PLI's trace, which is a measure of effect size, or can be interpreted as a measure of effect size, the F value, the F and the degrees of freedom, the F value, and the significance levels. You would then report a series of follow-up tests, And so you would do a series of univariate ANOVAs, of which we've done some in class, to find out where the differences lie. And again, you should be aware of multiple testing. So in conclusion, the personality profiles between these three groups differ. And that's the key point. So you could do follow-up tests, as I've just pointed to. You could do univariate ANOVAs. You could plot your data to see where the data lies. And you could also do something which is called discriminant analysis, which I won't cover, to find out more specifically how these three cultural groups differ from one another. That was actually all I wanted to cover for today. You can read a lot more on Manova, ANOVA, and ANCOVA in the references, which I will post at the end. Now, for your exercise, I want you to use last week's salaries data set. I want you to test the assumptions for an ANOVA with monthly salary as dependent variable and academic grant as independent variable. I want you to conduct an ANOVA with the appropriate post-hoc tests, and I want you to think about what you would conclude. So also have a look at the examples of a write-up. I would like you to conduct an alternative non-parametric test to the ANOVA. We've seen several in class, so I would like you to conduct one of those. So think back to the section on non-parametric tests, and again, I would like you to think about what you would actually conclude from the test, and perhaps you also want to write up the results as you would do in a sample report. Now, I would like you then to conduct an ANCOVA with gender as factor and year since PhD as a covariate. And again, I would like you to find out what you would want to conclude from that result. Now, we're going to do a different data set for the Manova test. I want you to load the IRIS data set. It's part of the datasets package. It's actually a famous data set with measurements of 3 species of iris flowers. I want you to test the assumptions for a Manova with species as the between subject factor and petal length and sepal length. That's a typo which I should correct, as dependent variables. I would like you to run the Manova. What do you conclude? And write up the results as you would do for a paper. And as a bonus, you would plot one of the results from your analyses on the salaries database. This is to test back to what you've done in lecture 2. And I would like you to conduct a follow-up analysis or plot for the Manova, which you've done. Now, here are some references and further reading, and some of them you can click and you can find out more information. That was all I had to cover. I hope to see you again next week.